A species of explorers. I'm sure you remember the first time you felt it, that sense of awe and sense of universal wonder. As a child, you looked up and saw the night sky in all its silent glory. It covered everything around you and was ever present. It was straight out beautiful, and you knew that it was important. You can look at it again the next night, or travel elsewhere, and it was still there, and still beautiful, and still important. As we grow up, we keep looking at the sky, and perhaps there are two overarching thoughts that emerge. First and foremost, there's a sense of unity of all humankind, because even though there's many different people at various places on Earth, and they look at their sky at different times or from a slightly different angle, we all have the same sky that we're under, and the same stars and the same sun shine on us. We're under the same firmament, like a huge tent, and in that tent we are united in our most fundamental experience of science and united in our human condition. The second element, though, if you share that experience with a child, is also evident. What happens? The child starts asking questions. These questions are an incredibly important positive thing and reflect the innate curiosity about our experience in the universe. And here's the secret. If you try to address those questions, you never stop looking at the sky and you learn more and more about the sky. The sky does not become less interesting, but more interesting, not less beautiful, but more stunning to all of us. The insights we get from science and telescope and robotic explorers enrich our view of the world in ways that we could not have predicted. We learn, for example, that the sky is nothing like the calm experience it pretends to be when we first look at it. This appearance is merely because of the mismatch of timescales of the change of the universe and our own lifetime. But stars are constantly being born and go through evolutionary histories, and so often end in violent ends that are explosions that are seen throughout the entire universe. This is seen throughout, wherever we look. Many philosophers have thought about that experience of looking at the sky, that experience of exploration that underlies the questions, these childlike questions. But it's the words of a child that I'd like to repeat here, the words of a child from the Artemis generation. He says, curiosity, insight, spirit, opportunity, if you think about it, are all of the names of past Mars rovers. Those are qualities we possess as humans. We are always curious and seek opportunity. We have spirit and insight to explore the moon, Mars, and beyond. It is inspiring to hear a young person who is truly in the Artemis generation reflected about the motivation of much of science that is reflected in the qualities we have as humans. They are qualities that our children often understand better than we do as grown-ups, and qualities that motivate us to go forward. It is the childlike why questions that are at the heart of what we do. It is beautiful and motivating, and it pulls us forward. It not only changes what we know, but also how we think about ourselves and our place on Earth and the universe. I'm going to repeat one part. Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans. We're always curious and seek opportunity. We have the spirit and insight to explore the moon, Mars, and beyond. Curiosity, spirit, and opportunities have brought us a long way in many different elements of our experience. We've been in space at the International Space Station for nearly 20 years, truly a marvel of international collaboration. We have learned about the views from space that many of those astronauts sent back just beautiful views of both our Earth coming together as one yet again, in unity, but also the aurora that are there at the edge of space and the upper atmosphere. We've learned about the changes of the Earth, also observed from there, and from other missions in orbit around our beautiful planet, the most beautiful planet we've ever seen, shaped by life itself. And we've learned about the other bodies in the solar system that are bizarre and so often in ways that we actually would have never predicted. There are questions still hidden in some of these data sets and new data sets that we're getting right now that we're only unraveling now. We've learned to look at the universe beyond that and look at our star, the sun, one of the most beautiful bodies yet again that we've yet observed, a variable star that's right there with us. We have learned a lot because of spirit and opportunity, but we have done it because of one more quality that we haven't talked about. We have done it because of perseverance. Because wherever there is exploration, wherever there is opportunity, wherever there is a pull forward, a question, the only way that relates to success is through perseverance. This year we're celebrating anniversaries for both the Hubble Space Telescope but also of Apollo 13. The Hubble Space Telescope is the most magnificent telescope ever built by humans, conceived by leaders like Lyman Spitzer and Nancy Grace Roman. This telescope was built with very tough challenges, both technically but also programmatically. And when it finally was launched and was released by astronauts into space, and the doors opened and it took the first picture, there was a huge disappointment. The telescope had the wrong optics. It was short-sighted and needed to be fixed. A disaster to many, a disappointment to everybody. But through perseverance, Hubble not only became the most successful astrophysics mission to date, but also the best demonstration of the confluence of and mutual importance of science and human exploration. With over 150 terabytes of data, over 12,000 researchers worldwide are working and have produced over 15,000 publications and adding about 1,000 publications per year ever since. There has never been a space mission with the scientific impact. Remember that it was enabled by perseverance of those before us. Take Apollo 13 the same way. I'm sure everybody hoped that it would go as smoothly as Apollo 11 and Apollo 12 before that. But starting with the famous quote, Houston, we've had a problem. The Apollo spirit and sheer excellence of the integrated team on the ground and in space came together and brought Jim Lovell and his colleagues back safely. The trip was full of innovation, ambiguity, and fear as the crew members worked with Jim Krenz and his ground troops to really work out solutions and innovate in ways that had never been done before. What initially looked like the most deadly disaster in the history of space travel turned into a story of leadership, of teamwork, and of unquestioned strength and success. It was perseverance, not giving up under pressure and when challenged, that got Apollo 13 back home. And that helped us be safer and accomplish the missions better the next time. Perseverance has always been part of exploration, and it forever will be. As I mentioned before, we are having big plans for NASA and our commercial and international partners. Using our Artemis program, we're moving astronauts out of low Earth orbit and forward to the moon. We want to go back and land with the first woman and the next man on the surface of the moon. We want to establish a sustainable presence at the moon and then move forward to achieve a goal we've never achieved, is to get astronauts to Mars. There, we can explore the same terrains and the same environment that our robotic explorers, that are so aptly named, have explored before. Make no mistake, it will be hard to go to Mars or to the moon. It always is. Our next rover is aptly named because it takes perseverance to survive and go this distance in the rugged environment of Mars. And all of our human explorers face incredible challenges as well. I believe we were meant to explore, but doing so makes us first face some incredible obstacles. We can face those with science and with perseverance. Let me talk about two elements that are critical in this realm: managing the dangers of space weather and sending science to lead the way for humans. We live in the atmosphere of a star, a G-type star, like there are billions of them, both in this galaxy and elsewhere. A star that at its core is powered by nuclear fusion. Nuclear fusion that burns about 4 million tons of hydrogen every second and creates so much heat that that heat, as it propagates out through the star, arrives at the surface of the sun and shapes it almost like the shape of a boiling pit, like an oil pan that you may see in your kitchen, turning over turbulent eddies. It's so hot, though, that much of the material, the solar material at the surface of the sun, is charged, and it's in a state of plasma. That state is very different than what we experience each and every day in our lives. But make no mistake, 99% of the entire universe in that shape of plasma. And in that state, that material is shaped not just by gas type of forces, but by electric forces, by magnetic forces that shape it and back react to the gas itself. That has a profound impact of how the sun appears. First of all, it makes it a variable star. A variable star in a timescale of about 11 years when the sun goes to a more active, to a more quiet state. But on timescales of hours and minutes, where energy in these fields can immediately discharge and flare up with very high brightness to create solar flares. And those flares, of course, are part of another phenomenon, which is the ejection of large amounts of matter in so-called coronal mass ejections that get thrown into space all the way beyond the planets. What we don't observe so well, but is equally important, or perhaps even more important, is that these ejections are interacting with the plasma, the solar wind that was already there, and are accelerating particles to very, very high speeds, nearly the speed of light. Those particles are not really hitting us here on Earth because we have such a thick atmosphere and also a magnetic field. But as we're leaving Earth and low Earth orbit, we're exposed to those particles. Now here's the problem, though. Most of those particles from these storms and the entire space environment are shaped in the solar atmosphere in a place called the corona, and we've never really observed that space, and certainly not the forces that shape it and the particles really close to it. But that's changing right now. As the Parker Solar Probe is getting closer and closer to our star and making measurements ever so close to this corona, this atmosphere of our star, and we're already learning new ways of looking at space weather. In fact, we care so much about that in addition to the Parker Solar Probe, there's other missions that are out there that we're launching. The first one, by the way, built by the European Space Agency Solar Orbiter, that will bring cameras to the inner solar system and also to higher latitude to look at the sun in new light from a different perspective to help us understand these connections. There's new observations from the ground, such as DKIST, but also in space, such as PUNCH and SUNRISE, with both use small satellites to make observations of that near solar environment and its emissions in totally new ways, and join the campaign to really reveal that important source of space weather and the source of our entire space environment. This is done just in time, because we want to be ready to support our astronauts with better predictions and our cross-agency partners with better predictions to actually warn them when energetic particles of the type that I just talked about come their way. In fact, we care about it so much that as part of the Lunar Gateway, we are putting a package, a weather station, onto the gateway and are making measurements, partner with the European Space Agency that put a whole radiation package on there just the same way. Just like seafarers, depending on the weather forecasts for their safe passage, spacefarers and our astronauts will depend on improved space weather forecasts that will come from these and other observations and model and theory development that we're working on right now. Again, it's curiosity, spirit, opportunity that pulls us forward. It is perseverance to these forces, to these challenges that will make this an unquestioned success. And as we're going forward to the moon and to Mars, science leads the way. We're taking more risk. We're going faster with our robotic explorers than we're going with our human explorers. We're willing to take risk. We're trying to go faster and learn how to train, how to learn about the environments we're going into. We know that it will be challenging, not just for our robotic explorers, but also the human explorers that will follow. Mars, as we learned, is both stunning and a challenging target. The fact is that nearly 50% of all Mars missions ever attempted by humans have failed. And it's one of the most difficult and challenging things ever achieved. Just with Apollo 13 and many moments in our history, we keep our cameras on during these moments, even though we know deeply about the risks that we're going to undertake that moment. We seek to achieve this goal again as we launch our next Mars mission this July. The instruments that are part of this mission have laid out to give us the information to collect the most valuable set of samples ever, samples of Mars, that we'll later bring back to Earth. Samples that are addressing the very simple question about, is there life elsewhere, a child might ask, related to Mars. This Mars mission is a true astrobiology mission, focused on the origins of life away from Earth and the conditions in which life might emerge. It has been hard to get this mission ready, and the team is hard at work right now. Who knew that we would see a virus as the highest risk to a timely launch of this mission, which last month was so aptly named Perseverance? NASA and its partners are doing everything possible to launch this mission on time because, just like the mission that will follow it, it is Perseverance that will ultimately achieve the big goals that yet again change the history books. In 2026, we want to launch a first mission back to Mars that is actually a launch vehicle that will lift these samples out of Mars and gets picked up by a European mission, and together as an international partnership will bring the samples back to Earth for study. The most precious samples at that moment in time will have extraterrestrial samples to study questions of life and many beyond that. But right now, as we prepare the Mars 2020 mission to launch, we find that the core qualities of Perseverance, so essential to this mission, are proving critical in these final weeks on Earth. And we will rely on this quality going forward, knowing that we will have to successfully land and operate the Perseverance rover on the Martian surface. All missions face own obstacles, but we'll keep going to chart a new story of humanity on another planet and in space in ways we cannot even comprehend yet. That is the story of exploration and the seed of perseverance in which we all rely on. A seed that grew from a necessary question of hope, a question of curiosity, and it's a quality that ultimately will bring it to its successful conclusion, perseverance. We are hopeful because the next generation who will complete this journey is inspiring. I've been using the words earlier in this talk from one of the students to frame this. In fact, it's Alex Mather, the 13-year-old who named the Perseverance rover. And I will end this talk with his words. Words about how humanity will persevere through exploration and beyond in the future.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans. We are always curious and seek opportunity. We have the spirit and insight to explore the Moon, Mars, and beyond. But if rovers are to be the qualities of us as a race, we miss the most important thing: perseverance. We as humans evolved as creatures who could learn to adapt to any situation, no matter how harsh. We are a species of explorers, and we will meet many setbacks on the way to Mars. However, we can persevere. We, not as a nation, but as humans, will not give up. The human race will always persevere into the future. My name is Alexander Mather, and that's why I chose Perseverance as the name of NASA's next Mars rover.
Don't you love this quote by Alex Mather? I certainly do. I love it very, very much. And as I'm sitting here, I'm thinking of all of you, and I'm wondering about your goals, your drive for exploration, or whatever drives you, and your stories of perseverance in it. Share those stories. Share them with us. Share them with others, because those stories are inspiring and are exactly part of what drives us going forward through exploration, to places we've never gone before, to experience things we've never experienced before. Thank you so much.